Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. To my fellow examiner, Dr. Istiqomah Subuki, and thanks for your time to examine my poster presentations. My name is Ilyas bin Azman. I am from class EH220AB, and my supervisor for this research project is Prof. Mada Dr. Junaja Jai. The title of my research project is Encapsulation of Kaffir Lime Citric Essential Oil KO by Complex Conservation Techniques. Over the time during my presentation, I will explain briefly about my findings and lab works through introduction, problem statement, objective, scopes, methodology, result and discussion, conclusion, and recommendations. I will start my presentation with the definition of kaffir lime. What is kaffir lime actually? Kaffir lime is type of fruits from a tree that have been cultivated in gardens and also cultivated in quite rarely in mixed orchid as a minor crops. This type of tree also have been produced in tropical rainforests in Malaysia. Most of Malaysians call these fruits kaffir lime as a lima purut in Malay. And the scientific name for kaffir lime is Citrus hystrix. From my study, we gain a type of essential oil from these fruits by peeling the skin of the kaffir lime and put it in hydrodistillation equipment. Through times, during the time, we obtain the essential oil. This type of essential oil, we call it as a kaffir lime oil. Kaffir lime oil have a lot of benefits such as mosquito repellent and also its contain antibacterial agents. But there also a downside for this type of oil, this type of essential oil, which is easily to vaporize or evaporate and it also shorten its effectiveness time. So this study also to overcome this problem by through a microencapsulations. Microencapsulation is process where we'll coated the oil with some type of material, oil materials, and its purpose actually to protect the compound against degradation and reduce by evaporations, and also to ensure the control release of the system and help the handlings. Actually, there's a lot of method to microencapsulate essential oil, but the one that I choose is complex conservation techniques. We will move on to the problem statements. The first one is citrus hystrix essential oil is also easily vaporized at room temperature with shortened its effectiveness time, which I explained before. Different essential oil have a different wall ratio and it also depend of its wall ration material. This is because that different essential oil have a different design to their wall material, different ratio, and it also depends on the material. In this study, we had choose chitosan and gelatin as a wire ratio material, but some of other researcher have used like Arabic gum and other material. So every time of switching of material, we need to change their operational their ration of the materials. So the next one is objective. The objective for these studies actually to determine the best capsule wall material formulation for complex conservation and encapsulation method, and also to determine the morphology and zeta potential storage stability of complex conservation, encapsulation, and emulsion. The scope to these studies actually to determine the data and formulation of this complex conservation technique to strengthen the capsule of kaffir lime essential oil through our analysis, which is zeta potential analysis, turbidity analysis, particle size analysis, surface morphology analysis, and storage stability analysis. I will zoom into the methodology. The next step will be methodology. I will explain step by step methodology or in my research. The first step will be establishing a wall ratio by zeta potential. In order to encapsulation to happen, we need to identify the zeta potential charges by those wall material. The wall material that have been chosen in the studies is chitosan and gelatin. Those chitosan and gelatin solution have been put in zeta sizer by Marvel company to identify their zeta potential charges with different set of pH range from 4.0 until 5.6 with interval of 0.4. In this step also we identify the pH with corresponding wall ratio value. The next step will be preparation of biopolymer mixture by turbidity analysis. In this step, we will mix the chitosan and gelatin solution and those mixture with corresponding pH with corresponding by using their wall ratio value. We put in UV vis to identify the turbidity. Those mixture with highest turbidity corresponding to their pH will be chosen as the wall ratio value. After find out the wall ratio value, the next step will be use the best wall ratio value in their encapsulation process. Will be include process of emulsification, co-observation, ultrasonic homogenize, dilution, cooling, crosslink, and harvesting. The next step will be the morphology analysis. After encapsulation process is complete, post-encapsulation solution will put under digital microscope to find out the morphology of the solution, to find out either whether the microcapsule is present or not present. The next step will particle size analysis. The post-encapsulation solution will put in master sizer to find the size of the microcapsule. The next step will be stability study, which the post-encapsulation solution will put in a beaker as a sample in a closed place with a constant room temperature for a few days to observe their changes. Now come to result and discussion parts. The first result that I would like to discuss is zeta potential and turbidity analysis. In order encapsulation to happen, we need to measure gelatin and chitosan as a wall material of the capsule to have opposite charges. If both of them have opposite charges, they could coat the cafe lime oil and form a microcapsules. And that's why we put the gelatin and chitosan solution with a different pH range from 4 until 5.6 with interval 0.4 to identify the charges under zeta sizer. So the result of the zeta potential analysis on the above graph, the orange line acts as a chitosans, and all the pH on the chitosan is positive charges, while on the blue line gelatin have both charges, which is positive and negative. For the blue line at gelatin, we also identify the IE point, which is isoelectric point. Isoelectric point is happen when the pH on that pH gelatin was at a 0 zeta potentials. So on the table below, we could see the results in value. We could see that only pH 5.2 and 5.6 they have the wall ratio value, chitosan ratio gelatin, because at the pH 5.2 and 5.6 have opposite charges between gelatin and chitosan. So pH 5.2 and 5.6 will proceed to the turbidity analysis. So what is a turbidity analysis? Turbidity analysis is when two type of polymer with different charges mixed together and become a turbid or cloudy condition of the solutions. So to choose the one of the pH to become a operating condition for the encapsulation process, we need to find with the highest turbidity. So we mix both gelatin and chitosan together with the corresponding pH and put them under UV-Vis to identify the turbidity. So after the turbidity analysis, we find out that at a pH 5.2 have the highest turbidity, which means with the highest turbidity, they have the highest electrostatic forces. So we choose it for the operating condition for encapsulation process. So pH 5.2 with chitosan ratio gelatin or wall ratio value with the value 18:1 will be chosen for the encapsulation process as operating conditions. The next result that I will discuss is post-encapsulation and morphology of the capsule. As we can see on the left picture is the beaker filled with post-encapsulation solution. The solution is cloudy with some precipitate at the bottom of the beaker. The right one is the morphology of the capsule under the digital microscope. As we can see, the capsule is present and spherical shape. The capsule also attached together, and this condition we call it clustering and agglomerations. The clustering and agglomeration happen because the free gelatin that harden after the cooling and settling process. This condition is common occurrence happen in most of the micro encapsulation process. The next result that I will discuss is a particle size analysis. After putting the post-encapsulation solution in the master, we have gained the result as the graph shown. The graph shown some data, and after some calculation, we have identified the main diameter size of the capsule is 91.741 micrometer, which is accepted by other researchers that range for the microcapsule that will be accepted is range from 1 to 500 micrometer, and the span of the capsule also can be accepted, which is 3.913, that is also be accepted. The last result that I will discuss will be the storage stability of microcapsules. So in this analysis, the post-encapsulation solution had been stored in a beaker and be left in a closed place for few days, and with a constant temperature of room temperature around 27 degrees Celsius. We can see over the time at the table below, the changes of color of the solution become more darker. The precipitation at the both of the solution have been dropped down to the below of the solutions. And for the each day of we observe the solution, we took a little of the solution to zeta sizer to observe the change of zeta potential. And over the time, we can see the zeta potential charges is increase in negative charges. So for the color changes, this is happen because degradation of the capsule. Degradation of capsule can cause the release of coffee lime oil to the surrounding solution and make the color more darker. And degradation of microcapsule also cause the precipitation that actually the capsule and drop down to the below of the beaker. And the reason behind why the zeta potential is increased in negative charges, because when it happens some fluctuation, some change in fluctuation of temperature or changes of temperature around 1 to 2 degrees will cause the increase of pH in surrounding solution, and cause the increase of pH will also cause increase of zeta potential in negative charge over the time. It can be proved from the table at the zeta potential table that I have been doing before, and we can see when increase on pH, the zeta potential in negative charge will be increased. The next part will be the conclusions. In the nutshell, the water ratio in order to form microcapsule as choose as design operating process for coffee lime capsule production of this study was at 18:1, which is ratio of chitosan and gelatin, and pH 5.2. Furthermore, for morphology analysis, it shown positive result, which means there were formation of a microcapsule that store the coffee lime oil. Then for size of microcapsule through the master sizer, the mean particle size was 91.741 micrometer, and it was acceptable as it had ranged from 1 until 500 micrometer. Furthermore, the storage stability, it can be concluded from post-encapsulation solution that the zeta potential increase and it changed appearance over time. It's due to the minimal fluctuation of temperature over time, affect the pH of surrounding solution, and the degradation of microcapsule that cause the release of coffee lime oil into surrounding solution. And the lastly is recommendation. The first one is increase the range interval of pH for better accuracy of design operating condition. The second one, need to properly filter the solution sample before carry out zeta potential analysis. The last one is the cuvette need to properly clean by wiping before using zeta sizer and UV vis equipment. That's all for me. Thank you.